Good day, class. Today, we are going to learn another topic. I am Francis S. Corpus, and I am your teacher for today. So before we start with our proper discussion, I have prepared a short activity. All you need to do is just to guess what is our topic for today by showing you the four pictures. So as you can see, there are a galaxies and also a telescope and a magnifying glass. So what do you think is our topic for today? Yes, very good. Our topic for today is observation to the distant galaxies. So before we proceed with our discussion, let me read first our objective. So the first one is to explain how astronomers use light to learn about the distant galaxies long ago. Second, discuss the instrument used by the astronomers to observe the galaxies. And lastly, discuss the evidence showing that the first stars formed when the universe was less than 10% of its current age, just like our universe of 13.8 billion years old. So let's proceed. So what is a galaxy? So galaxy is a gravitational bound of a system of stars, stellar remnants, stellar gas, dust, and dark matter. So this is the combination of, in the galaxies there are a group of stars and what I have mentioned earlier, like gas and dust, and also the dark matter. The galaxy's appearance and composition are shaped over 1 billion of years by interaction with the group. So and stars and other galaxies. So as a galaxies getting older, a lot of interaction inside the galaxies, like stars, gas, dust, dark matter are interact with each other. So next, so how astronomers use light to learn about the distant galaxies long. So as you can see in the picture in the right side, that is what the telescope inakuha ng telescope. So the true color long exposure image made during the 70th orbit of the Earth with the Hubble Space Telescope. So this is the instrument used by the astronomer. It shows a small area in the direction of a constellation sculpture. The massive cluster of galaxies named a belt 2744 appears in the foreground of this image. So it contains several hundreds of galaxies, and we are seeing them that as they look like 3.5 billion years old or billion years ago. So the immense gravity in a belt 2744 acts as a gravitational lens. Then to warp space and brighten the magnified image of the nearly 3,000 distant background galaxies. So the more, it was stated here that the more distant galaxies, or many of them quite blue, appear as they did more than 12 billion years ago. That after the Big Bang, blue galaxies were much more common in that earlier time than they are today. These galaxies appear blue because they are ongoing active star formation and making hot, bright blue stars. So next slide. So this is the big question. If we can directly detect the changes over the time in individual galaxy because they happen to slowly, how then can we ever understand those changes and the origins of the galaxies? So the solution is to observe many galaxies at many different cosmic distance, and therefore look back by looking back times, or how far back in a time we are seeing the galaxy. So if we can study thousands of very distant baby galaxy when the universe was 1 billion years old, and another 1,000 slightly closer toddler galaxies when it was 2 billion years old, and so on until the present, which is a 13.8 billion years old universe, just like what I said earlier. So this is the adult galaxies near us today. So then maybe we can piece together a coherent picture of how the whole ensemble of a galaxies evolved over the time. So this allows us to reconstruct the life story of a galaxies since the universe began, even though we can follow a single galaxies from infancy to old age. So in the next slide, in addition to the distance and look back time, studies of the Doppler shifts of a galaxy's spectral lines can tell us how fast the galaxy is rotating, and hence how massive it is. So detailed analysis of such lines can also indicate the types of star that inhabit a galaxy and whether it contains a large amount of the stellar matter. So unfortunately, many galaxies are so faint that collecting enough light to produce a detailed spectrum is currently impossible. Astronomers thus have to use much rougher guide to estimate what kinds of stars inhabit in the faintest galaxies or their overall color. Next, what are the evidence that showing that the first star formed when the universe was less than 10% of its current age? So, spectra shows old red stars in the galaxy. So as you can see in the picture in the right side, that are those red stars. So spectra shows old red star in the galaxies that are so far away that we are seeing what they were like not long after the universe began. So stars were only billion years old, died and spewed out elements. Composition and gas in its quasar means that it already cycled through the star and during the first billion of years. So next, we have three different types of galaxy, or based on their composition. So we have the spiral, ellipticals, and irregulars. So spiral has a mass of 10 raised to 9 to 10 raised to 12 than mass of the star. Its luminosity or this brightness is 10 raised to 8 or to 10 raised to 11. So that's more than the luminosity of our sun, of our star, which is the sun. So the ellipticals has a mass of 10 raised to 5 to 10 raised to 13 mass, more than mass of the star, of our star, which is the sun. And its luminosity is 10 raised to 6 to 10 raised to 11. And lastly, we have the irregulars galaxies. Its mass is 10 raised to 8 to 10 raised to 11. So almost the same as the mass of the spiral galaxy. And the luminosity of these irregular galaxies are raised from 10 raised to 7 to 2 times 10 raised to 9. So that are the different masses and luminosity or the brightness of the different types of the galaxies based on their composition. So that's all. I hope you learned in this discussion. Thank you and God bless.